Okay, I think the screen is visible to you. Um, yeah. So we have some. Anyone can give something about peripheral interface controller, PIC microcontroller. It's a microchip company. We are going to study about PIC 16F877. PIC 16 is a third family of the PIC family, manufactured by microchip company. F stands for flash memory is available, and 877 is the number of the chip. Okay, so we have seen the architecture. We have seen one by one central processing unit, then memory organization. We have three memories are there. I think yesterday while I'm taking the class itself, the power supply has gone, so obviously it is disconnected, so we don't have concluded the class. So first we are going to see the architecture of PIC 16F877. Okay, you have to understand that PIC microcontroller architecture is very important question on this unit. So first we have discussed the central processing unit, and then memory organization. Three memories are there: program memory, data memory, RAM memory is there, data memory, EEPROM memory is there. Okay, so program memory we have seen 8 kilobytes are there, and we have seen it is a 13-bit program counter. We have a page structure, 4 pages are there, each page having 2K. Okay, so data memory also in the form of bank. So each bank having the capacity of 128 bytes. So 4 banks were there. Okay, so this I serial communication we have discussed. SPI serial peripheral interface, inter-integrated circuits, USART, and interrupts we have seen, timers we have seen, CCP model. I think at that time only the power have been cut. Capture, compare, PW model. What is the purpose of this model? Now, this particular module is used to generate the uh, waveforms, PWM generation, especially for the PWM generation, especially if I want to generate 8051 microcontroller, I can generate only a square waveform. I can't generate rather than other waveforms. But here using CCP model, I can turn on and turn off my devices with the various switching frequencies, because capture and compare module will do that, and PWM mode will generate that. So that is the main advantage of that. I think while I'm explaining this only, the supply has cut off. So once again, I will share the whiteboard. I think capture and compare. See, this is my carrier waveform. Okay. It may be in any form. I have drawn like a sawtooth waveform. It will be in a triangular waveform. Okay. And this is the reference wave. Okay. So whenever that I am comparing, it can able to generate the pulses. So whenever that value is equal, it have a can able to generate the pulse. I think this capture compare PW model you already studied in the TMS, that is a Texas DSP processor. So the same thing. So I can change my frequency. So here um, uh, by uh, by changing the reference wave, I think if my reference wave is here, obviously what happen now, my PWM having a high on period. Okay, it have more on period and less off period. So that have a capability here. Okay, but in 8051 we can able to generate only one square pulses. So that is not here we can generate various square pulses. Okay, so I will share the PPT now. Okay, so CCP model is there, then IO ports. Okay, so input output ports are there. So I think wait ma. Wait, I have shared some other PPT. Actually, the same file name I thought of. Okay. Actually, yesterday is told in one family only it having a 20 interrupt internal interrupt. Here it have only 14 interrupt. The remaining and all same only. Three timers are there. Two timers are 8-bit timer and one timer is 16-bit timer. Okay. Now we will enter into IO ports. Okay. We will see what are the pins available in 80 sorry PIC 16 of 877, and you have to remember one thing here. Here we have 5 ports are there. Did you remember there how many ports are there, ma, in microcontroller? 8051 microcontroller. How many ports are there?
4.
4. Very good. What are they, ma?
Port A, Port B.
P0, P1, P2, P3.
No, port.
Port 0, port 1, port 2, port 3.
Very good. Port 0, port 1, port 2, port 3. So we all know if I want to connect any peripheral devices, it is easy to connect via ports. We don't need any interfacing ICs. That is the one advantage. But here we have a 5 IO ports are there. So totally 33 pin they are allocating for. You all know it is a 40 pin structure. So 33 pin they allocated for the ports. So here we will see the ports one by one. Port A, and you all know 33 pin, no, all the ports are not the 8-bit port. You have to understand. Okay, port B, port C, port D, only 8 bits. So 3 into 8, 24. Okay, port E is 3. 3 pins, so 27, and port A is 6 pins. So totally, while I am discussing about this, port A having 6 pin, and port B, C, D having 8 pins, and port E having 3 pins. So totally 33 pins are there, but there we have a 32 pins because all the 8 ports are there, all the 4 ports having 8 pins. So 4 into 8, 32. Here 33 pins are used for input output operations. Okay. So while we are seeing that all the ports are the bidirectional ports. So we have seen 3 registers only I have seen. While I gave you that, I think you can be able to see status registers, port registers, trace registers. So the trace register is a data direction register, input output port, and port register is mainly for assigning 0 to and 1 to the ports, whether it will act as an input port or output port. Status register is mainly used to switch over the bank. Where which register we will use for selecting the bank, ma, in 8051? In 8051, which register we have used to select the bank? Which register is used to select the bank in 8051? You all forgot which register is used to select the bank registers? Anyone? Anyone, ma?
R0 to R7.
Uh, Actually, you all know 2 pins, RS0 to RS1. Okay, that 2 pin is available in which register?
D3
RS.
and D4,
Huh?
ma'am. D3 and D4.
Pin is not, I am not asking the specific location. I am asking that particular pin is available in which register? Name, huh? Which register, ma?
PSW, ma'am.
Very good, very good. PSW register, program status word register. That 2 pin is used to select the bank register. So here that purpose will be saved by which register, ma? Status register. So status register is used to select the banks here. Okay, now we will see Port A is a bidirectional relay. It is corresponding data direction register is TRISA, TRISA. If TRISA port pin is, we all know, 1 means it will serve as an input port, and 0 means it will serve as an output pin. That you did you remember? There we use the D latch and a buffer, input buffer, output latch and all na, that we have explained. And from that we have seen 1 means it will serve as an input port, and 0 means it will serve as an output port. Okay, so similarly port A 6-bit. uh, okay, similarly, while you are seeing port B is a 8-bit bidirectional bit. So here data direction register is here TRASBA. Here Trisha A correspond to port A, Trish B correspond to port B. Okay, again the same thing will be, pin is said to be for um, input port, and 0 means output port. This port is mainly used for data transmission. Port A mainly used for analog inputs. Okay, we all have a external future is there. So analog to digital converter, digital to analog converter are there. So port A is used for analog input, and port B is used for data transmission. And while we are moving on to port C again, it's a 8-bit wide bidirectional, and data direction register is TRISC. Okay, again it will serve 1 means input pin, and this is mainly for control register. If I want to do, we all know, serial communication, which register will control the serial communication, ma? What are the registers in the serial communication? There we seen serial communication registers in 8051. Serial communication registers in 8051. Why not
Con Pcon, ma'am.
SCON and
SBA.
PCON? Very good. Then
Serial data
Serial buffer,
register.
serial buffer, then serial SMOD register. Okay, so we have a serial control register, TMOD register is there, serial control SCON register is there, serial buffer register is there, and PCON power con register is also there. So serial here also serial communication. Okay, I square C. What is the full form of I square C? Inter
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 Communication
integrated
protocol.
circuits. Okay, so we have seen I square C, USART, SPI, or the serial communication protocol, mainly for serial communication register. Okay, so port D is also 8-bit port, and it is used as a data port. Can you understand or not? Okay, the data direction register is TRISD, and port pin once in, it will serve as an input pin. Port 0 means it will serve as an output pin. So I think, even though the family of the PIC microcontroller is different, but when you look upon that, the working and the similarity will be same only. Okay, and port E is used for mainly for read, write, and chip selection operation. Okay, and each pin is similarly input and output, and is used for controlling purpose. So read, write, and chip selection, you all know, PIC microcontroller, if I want to interface any other chip, if I want to read the data, write the data, particularly because it's a 3-bit wide, this is will be used. So you have to understand a small recap on port A. Port A is used for analog input, port B for data transmission, and port C for serial communication, that is for control registers, and port D for data port, and port E for read, write, and chip selection. So we all know, port B, C, D. Port B, C, D, 8 ports, and port A is a 6-pin port, and port E is 3-pin port. You have to understand. So 5 ports are there. So totally out of 40 pin, 33 pin they allocated simply for the ports. Okay, then definitely it have also a digital to analog converter. Mainly you all know the digital to analog converter. So when I receives any digital input, if I want to convert into analog, that purpose also served in the PIC microcontroller. And similarly analog to digital converters is also there. So my voltage level is between 0 to 5 volt na, it have a resolution is 10 bit na, it have a resolution of 1024 levels will be there. Okay, So it have some specific registers also there, analog to digital converter. Okay, and we have a capability to convert both. Okay, and one more important feature of PIC microcontroller is watchdog timer. Actually, it's one of the important two mark question. Even in PIC microcontroller, you are supposed to write about watchdog timer. It's like a timer only. So watchdog timer is even why it is mainly used na, if watchdog timer is cleared through software each time before, actually I can clear through the software also. Even software is also failed, my watchdog timer will reset the system. So we will use a backend. Even software, if I'm writing any coding, if the particular software coding is failure, at that time the watchdog timer will be enabled, and it will do it will serve the purpose. So it mainly for real time applications we will use. So if I want to wake up the microcontroller from sleep mode, you all know sleep mode is nothing but a, we always know the power saving mode. How in our laptop we have a sleep mode is there now. So automatically, so in this microcontroller also we have a power saving mode, sleep mode also there. So watchdog timer is nothing but a, it's a countdown timer only. I can preset some value. So after 120 seconds, it has to be awake. So at the same time, if my software is failure, automatically what happened? The watchdog timer will be enabled, and it will serve the purpose. Okay, it's nothing but a timer. Timer is nothing but it mainly it's a countdown timer. Joshua, Joshua, put your mic in mute, ma. Okay. So watchdog timer is also loaded with the timeout period for the independent application. Okay. So the entire before now only I am going to show the architecture of PIC microcontroller. So PIC microcontroller, while I am discussing, first we have discussed about the CPU, central processing unit. Okay. The first one is central processing unit. CPU we have discussed. There it consisting of all this ALU, memory unit, control unit, accumulator. Then the second is memory organization we have discussed. So while we are discussing memory organization, three memories are there: program memory, data EEPROM memory is there. So that we have discussed. Okay. After that, we have discussed about the serial communication module. The third one is serial communication, and fourth one is interrupt, and fifth one is timer. Okay. And sixth one is CCP module. Okay. And the seventh one is IO ports. We have discussed about all the input output ports. So five ports we have seen, and eighth one is digital to analog converter, and ninth one is analog to digital converter. And I have explained about the watchdog timer also. Okay, now we will directly enter into the architecture, and then we see the features. Okay, this is the architecture of the PIC microcontroller. Okay, now we have discussed about one by one part. So first what we see now, central processing unit. What the central processing unit, ma? What the central processing unit consisting of? ALU unit, memory unit, control unit, accumulator. So here I think I will use some other pointer. Have you seen? This is my ALU part, arithmetic and logical unit. Okay. Now, what is the length of PIC microcontroller, ma? What is the length of PIC microcontroller? It's a 8-bit microcontroller. So definitely my ALU unit also having 8-bit. Okay, W register. The full form of W register is working register. Working register means how we say accumulator, na? That is the working register here. Don't get confused. Accumulator only. They say W register, and W register is nothing but accumulator. So ALU and W register will be there, and you all know multiplexer. So multiplexer will always receive the address and data line. So according to that, it will fix into multiplexer means what? Multiple input and a single output will be there. So multiple input, it will receive the address as well as data, and then it will convert, and which has to be enabled will be decided by the marks unit. So you all understand this is my ALU register. Okay. So apart from that, we have a two registers are there: FSR, status register. And status register only I told you, status registers will play a role to select a bank. How PSW register is? What is the purpose of PSW register, ma? Anyone tell what does PSW will register will do? PSW register consisting of what, ma? What PSW consisting of? In
Program
8051 I am
status code.
asking. Tell me, ma.
Selecting the bank register, ma'am.
And then not only selecting the blank register, what is the another name of PSW register?
Carry flag, ma'am.
Flag register, not carry flag. PSW register, the another name is flag register. It always denotes the flags also. Auxiliary carry flag, parity flag and all. Similarly, the same PSW, because the manufacturer is different. There it is a Intel manufacturer, it is a microchip manufacturer. So just they will change the name, but the purpose will be same. So status register is nothing but what the purpose PSW will same purpose will be served by the status register. Are you clear, ma? So here when you see that what is the status register now, status register is also used to select the bank, and the carry flag, auxiliary carry flag, zero flag also consisting in the status register. We will see separately the status registers 8 bits. Okay, then FSR, file select register. You always understand that my registers will be in the form of the banks, and we all know we have a 4 banks are there. So that general purpose registers will be there, special function registers will be there. So which has to be served? So we always have a FSR, file select register. So whether it I want to select through indirecting mode, direct address, here we have only two addressing modes, direct addressing mode and indirect addressing mode. That's why see here they have put direct addressing mode, and here indirect addressing mode. So the two way I will select my address. Can you understand or not? So this is my part. What we studied, ALU in CPU. What are the main part, ma? ALU, working registers. We all know mux will be always there. Then status register and file select register. Okay. Now, have you seen here? We all know PIC family 10, 12, 17 will be there. So PIC 16F877 is one configuration. PIC 16F874 is another configuration. But both the diagram will be same. One more thing, while you are searching for PIC, you are always has to be very confident in your number, because PIC microcontroller, na, a general PIC microcontroller, 4-bit, 8-bit, 12-bit, 4-bit, 8-bit, and 32, 16-bit, and 32-bit will be there. So you have to be more confident which PIC microcontroller you are searching. So here PIC 16F877, we have a 3 memories there: program memory, data memory, data EEPROM memory. You have to understand program memory is 8K, 4 pages are there, each page 2K. Okay, and data memory is 365 bytes. Data EEPROM is 256 bytes. So you all understand this is small my on chip memory only. So on chip in PIC microcontroller we have a memory. 3 memories are there: program memory, data EEPROM memory. There we have ROM and RAM memory only. Here we have ROM memory, RAM memory, stack memory is also there, because we have a 8 level of deep stack is there. So you have to understand that this is my flash program memory. We all know flash memory means whatever I have written the program, I can able to burn the program and I can write my new programs there. So this is my flash program memory. And we all know what is the flash program memory capacity? 8 kilobytes. 8 kilobytes na 8161 locations I can search. So in hexadecimal, the value is 1FFF. So totally how many bit they allocated, ma? 13 bit they allocated. Are you clear, ma? 13 bits they have allocated. So 13 bits they have allocated. Now see, from the program counter, uh, 0 to actually not we used to say G0, D1, D2, D3, D. So it's a 13-bit program counter. It will sense. Okay, so that is my 13-bit address. Can you understand or not? It's a 13-bit wide program counter. Okay, the next one is we all know what is the length of data bus, 8-bit only. Okay, so and see It's a 8-level stack that is also specified. 8-level deep stack is there, so it is also specified. And RAM, in the RAM we all know all the general purpose special function registers will be in the RAM only. So this is my data bus and this is my address bus. Okay. And then instruction register. So in the instruction register, you have to know that all the instructions are we used to configure in a 14-bit. So that's why we will, while we are seeing in that why it is 14, I will explain. Here 13, here 14, I will explain you. So 14. So to select whether it is a direct address or indirect address. So mainly to that you used. Okay. Then instruction decoder and control. What is the purpose of instruction decoder and control, ma? I think this instruction decoder you are keep on seeing from 8085. What does instruction decoder will do? Anyone? Instruction decoder and control. What the instruction decoder and control will do, ma? Hey, I'm saying this is one of the important question. I thought your CAE patterns are in that. It's a one of the important architecture we were discussing. What is instruction decoder and coding? What the instruction decoder will do, ma? The name itself you can say. Hey, tell me
It
anyone,
will
ma?
decode the instruction.
Ah, ma?
Decode the instruction.
Yeah, it will decode the instruction. You all, the name itself, I'm saying decoding. We all have three operations. What are the three operation, ma? Fetch, decode, execution.
Read and
That is the three operation. Always remember fetching the instruction, decoding the instruction, executing the instruction. Decoding means for example, if I give move, what happened? Definitely it will move from register to accumulator or according to the instruction. Sub, it will subtract the content. XRL, it will exclusive or. So for each and every instruction you have a opcode. So that a particular opcode is in hexadecimal, so that it will convert into a machine code. Machine code means it will be in a binary bit. So for each and every instruction, it will the microcontroller will decode. So without this instruction decoding and control, we can't have a capability to understand what the instruction is fetched and how it is to be executed. So instruction register will be there. So definitely we'll go for instruction decoding and control. Why control? Na read write operation. Okay. Timing generation, you all know. This are all about oscillators. I will discuss later. Next you come instruction decoder and counting. Now, how many registers are here, ma? How many registers are there? How many registers are there?
8,
Now,
ma'am.
three registers. Very good. Timer 0 and timer 2 are my 8-bit registers. And timer 1 is my 16-bit register. You all understand? My timer 0 is connected with data EEPROM. Okay, so electric that is true that I have to access. And timer 1 is connected with the CCP, capture compare model. We have a two capture compare model is there. So capture compare PW model, two module is there. And timer 2, synchronous serial port. We have seen that now, USART, SPI model, or that it will be served by timer 2, not USART. Actually, USART is separately connected. SPI model is will be served, and I square C will also serve here. Then 10-bit A to D, 10-bit resolution. You all know 2 power 10, 1024 levels will be generated in analog to digital converted. So there it is connected with the USERT. And then parallel, now you come to here. How many bit ports, ma? Uh, Nearly 5 ports are there. Port B, port C, port D. It is connected to, it is having 8 pins, and port A is connected with 6 pins, and port E is connected with 3 pins. We all know port A will mainly serve the purpose of analog. I have given you and I have listed you. Port A for what, ma? Analog inputs. Once again recall, port B for data transmission, port C for control registers, and port D for data port, and port E for read write chip selection. So similarly, you have seen port A for analog input selection. Okay, and port B Port B mainly for data transmission, and port C is mainly for what ma? All the serial registers and all, I square C. And port D, Huma, kindly put your mic in mute, ma. Port D serves as a data port, and port E will serves mainly for the read, write, chip select bar, read bar, write bar, and chip select bar. So you all know all are bidirectional ports. That's why I think this pins. It's a actually, while I will discuss separately all about this ports, then we will see about this pin. Can you understand? So now you just remember port A, port B, port C, port D, and port E for analog and for data transmission and for serial register control purpose. And this is also used for a control registers, and this is for read, write, and chip select bar. I think you can understand the PIC microcontroller entire organization. So here, apart from that, you have to understand all these are the timers of the microcontroller. What is the advantage of now? Mainly what now, we have a inbuilt timer is also there. Apart from that, you are see power up timer, oscillator startup timer, power on reset. Reset is as usual button. Okay, watchdog timer, brownout reset. Okay, power up timer, it's mainly for the timer we will use. Oscillator startup timer, actually in oscillator we have a prescaler, whether I want to increment or decrement, or I want to change the value of that, we will use the oscillator timer. Then power on reset purpose we will use. Watchdog timer, it is mainly even software fails, this particular watchdog timer will be enabled, and you have to load the value that it will be keep on decrement the value. Brown on reset, that is nothing but brown up reset is that if I want to save the mode, you see understand, I have a 5 volt, so in the 5 volt every time I keep on use the 5 volt now, obviously my power storage of PIC microcontroller will be wasted. So for that, whenever my power is not needed that much, the 2 volt 0 to 2 volt is enough odd at that time, power brownout reset will be automatically enabled. So if I want to save the timer, if timer want to be enabled, or else it has to go to the sleep mode or ideal mode, for that purpose we have a different kind of timer will be there. Okay, it's a nothing but a clear and input and ground, and this is nothing but a oscillator pins. Okay, so PIC microcontroller architecture is a one of the important architecture, and it is an important question in the third unit. Actually, first question we have seen CISC and RISC, and the next question we are going to see will be 5 ports. Okay, 5 ports are there. ALU unit is there. Then 2 registers will be there. Then ROM memory is there. RAM memory is there, stack memory is there, EEPROM memory is there, and this is a mainly to select. We have 2 types of addressing mode: direct or indirect addressing mode is there. So it is a 13-bit. What is the capacity, ma? 8 kilobytes ROM memory, 256 bytes RAM EEPROM memory, and 368 bytes RAM memory is there. Okay, 3 timers are there. Analog to digital, digital to analog converter is there. Parallel slave port is there. PSP they used to say. Parallel slave port is there. Synchronous serial port is also there. USART port is also there. Are you understand or not, ma? While you have to write a PIC architecture, please kindly write this is the PIC microcontroller futures, and this is the peripheral future. You all know what are the peripheral future, ma? Timer 0, timer 1, timer 2. Okay, so I told you prescaler means what? I can able to divide my clock frequency, that is prescaler. And similarly I can use my external clock also. Internal clock is cannot be used. Sorry, internal clock means it will, we all know timer and counter operations are there. So depending upon that, so if I want to use the external clock, that is mainly for timer 1, I can use with the external clock. Okay, then capture compare PW model. 2 capture compare is there. How many bit they are allocated, ma? 16-bit and resolution. I told you, while I want to generate any waveform, I can use the capture, compare, and PW model. And 10-bit analog to digital converter is there. Synchronous serial port is there. Okay, and we all know I square C SPI will be supported there. Then USART is also there. Parallel slave out is there. Brownout detection. My circuit want to work with 0 to 2 volt. This cell will be suffer. You may ask, ma'am, directly why you didn't teach now. If I told like that, it will be somewhat less. So that's why I have listed out what is CPU, what is memory organization, how many interrupts are there, how many timers are there, and what is CCP module, and what are the ports available, and what is serial communication, and A to D converter, D to A converter, we are separately. But while you explain architecture, please write these 2 points enough. So this is used though. It is a RISC CPU. 35 single words are there. Okay, and okay, we all know 8 kilobyte is there a program memory, 368 bytes data memory, 256 bytes EEPROM memory, 14 level of interrupt, 8 level of hardware stack, direct, indirect, and relative addressing mode. But we will see direct and indirect. Relative addressing modes, while we are seeing in instruction set, we will see power on reset, power up timer, oscillator. This all about timers. Okay, sleep mode is available, and we have a low power, high speed. You understand? Low power means depending on oscillator, we can work with 2 volt. High speed means frequency. What is the frequency, ma? Just see, we have seen only with 12 megahertz. Here you have seen 20 megahertz. So that's why they are saying low power, high speed. 0 to 2 volt also work. It will work with the 20 megahertz. And the in circuit serial programming is also possible, that we have seen. Synchronous serial port is there, parallel slave port is there. Okay, and then read write operation is there. My voltage range is 2 volt to 5 volt, and my the current value is 25 milliampere, and low power consumption. You have seen that it's a low power consumption devices, and commercially and industrial and extended temperature ranges. While working too much, we were putting the oscillator in the maximum temperature, so it can operate in the wide temperature range. Have you understand about PIC microcontroller, ma? Have you understand about the PIC microcontroller? Yes, yes or no?
Ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Coming late. Okay, now 11:42. Okay, tell me the difference between 8051 and PIC. Actually, mm. A, oh my God. Mm. Yeah, you have to tell me. You have already understand. Can you able to view, ma? Uh,
No, ma'am.
no, you can't view. Whiteboard only I'm sharing. Uh, yeah, now it is visible, ma.
Yes,
Now,
ma'am.
yeah. Mm, tell me some differences. Tell me the differences, ma. Subbulakshmi, tell one difference. Everyone has to tell one difference. That much of difference is there. Subbulakshmi, Subbulakshmi, what? Tell me. Tell me the difference between 8051 and PIC. Tell me the difference. Where you are searching? Because I'm not going to show the difference. Yeah. Sublakshmi, are you here, ma? Sublakshmi? Sublakshmi, are you here?
Yes, ma'am.
Yeah, tell me one difference. Why this much time? No, I have listed out so many things. Tell me the difference. Yesterday I have called one person, he didn't there. I think Ragulkar. Ragulkar is today present. Ragulkar,
Yes, ma'am.
tell me one difference. Sublakshmi, tomorrow I will start the question with you. Ragulkar, yesterday where you went? While I'm keep on
Ma'am.
calling you are there. Now, tell me what Sublakshmi.
Okay, ma'am.
Okay, so only you are saying. Oh, I'm sorry, I thought you were telling the answer. Okay, Ragulkar, tell me another difference. Hey, who is the manufacturer for PIC 8051 ma? Ragulkar, you're driving. You're in driving.
இல்ல மேம் பேங்க்ல இருக்கு.
பேங்க்ல
நோ மேம்
இருக்கியா?
பேங்க்ல இருக்கு மேம். எஸ் மேம்.
பேங்க்ல போய் கிளாஸ் அட்டெண்ட் பண்ணிட்டு பேங்க் போறது. பேங்கிங் டைமே எக்ஸ்டெண்ட் பண்ணிட்டாங்களேப்பா. Tomorrow the first question session will be for Ragulkar. Next, 94. 94. Register number 94.
Ma'am.
Vinoba, tell me one difference. Yeah, I'm asking difference.
Ma'am.
Tell me, ma.
In 8051 memory organization வந்துட்டு RAM ROM ma'am.
Very good. She
PIC
say
வந்துட்டு RAM ROM stack ma'am.
very good. RAM. Actually, here வந்து RAM, ROM. Very good. Here RAM, ROM, stack. அதாவது ROMங்கிறத விட we have a EEROM.
EEPROM.
EEPROM. Okay. Very good. First point she said. And the next step.
Interrupts, ma'am. 8051 5 interrupts.
இங்க
PIC
இங்க
வந்து 20, ma'am.
20 episodes. I told you it's other thing. 14 interrupts only. Okay.
Okay, ma'am.
Okay.
In 8051, on-chip memory is 4K, ma'am.
Very good.
4 kilobytes.
Somebody is telling. Okay.
Yes,
If on chip is
On-chip memory is 4 kilobytes, ma'am.
4 KB. Okay.
Yes, ma'am.
Then,
In PIC, 8 KB, ma'am.
okay. 8 KB ROM. Then.
Ma'am, 8051 ல 2 timers ma'am.
Very good. 2 timers.
PIC ல 3 timers ma'am.
Very good. 3 timers. Then.
Ma'am, PIC microcontroller வந்து risk based instruction ma'am.
Very good. Very good. Super difference. Who is saying, ma?
Aruna Devi ma'am. Aruna Devi ma'am.
Aruna Devi. Very good, Aruna Devi. It is CISC based and this is risk based. Okay. Then, how many instruction in 8051?
Harvard architecture.
How many instruction
Harvard
in
architecture, ma'am.
12 man.
12? 8051, how many instruction? 2? 255
instruction.
PIC
35 instruction.
35 instructions. Very good. Other difference?
It supports UART, USART, SPA,
Yeah, super. Who are told, ma? Who is saying this? Jayprakash. Very good. He said that here we have only UART, but here we have a USART. Then apart from that, what have we have, ma? SPI, I2C, parallel slave mode, different types of timers module is available, protocol is available. Then Any other
Power
difference?
consumption is medium and power consumption is
Yeah,
low,
ma?
ma'am. 8051 power consumption is medium, ma'am. 80 for PIC power consumption is low.
Yeah, power consumption is low and here it is high because we have so many power setup modules are there. We have a brown up register is there, power on timer is there, that is available. Okay, I think you are given so many differences. Thank you, students, ma. And some of them were behaving, attending, putting the mic and moving somewhere else. uh, I don't know. You have a lot of time to listen. Okay, this is the difference I have given that. Actually, in PIC microcontroller, it is 8. Okay, wait. Actually, it is especially they were comparing the family. Can you understand or not? Okay, so both are 8-bit. Actually, this is also 8-bit. PIC 16F877. That is also 8-bit. Okay. Then communication protocol. Actually, here we have UART only, but here we have a UART I square C SPI are there. So here you see we divide 1 by 12, but here we divide 1 by 4. Okay, and memory. Actually, they compare Intel family. We have only ROM and RAM memories there, but here that's why I didn't take this difference because they compare the family, not compare the single processor. Can you understand or not? And 8051 is mainly a 8051 is mainly Intel manufacturer, and PIC microcontroller is a microchip technology.
Microchip.
Okay, so while we are seeing about this, what is the operating frequency there, ma? 12 megahertz, but here it is 20 megahertz. Are you clear? Can you able to see? There it is 12, na? Is it 20 megahertz? And then we have a power on reset, brown up on reset, watchdog timer, oscillator are there. But there we don't have we have only power on reset is there, oscillator is there. We don't have a watchdog timer is not available. Here it is 8K na. Here what is the memory ma? 4K. And here data memory is 368 bytes na. Here it is 256 bytes. And data EEPROM, here they know EEPROM is memory is available. Here 14 interrupts na, here 5 interrupts. Here port A, B, C, D na, here port 0, 1, 2, 3. Okay, here we have a 3 timers now, we have 2 timers only. And here we have a capture compare model now. Here we don't have any capture compare model. Serial communication, here only UART is there, no parallel communication is there. Okay, so analog and digital model is, oh my god, analog and digital model, it's not specified there. Okay, instruction set we have a 255 instructions. So this is the comparison. So you have to understand that my which is advanced ma? PICA 8051 na?
Pick, ma'am.
PIC is advanced, but what is the disadvantage in PIC na? We can't able to write the short programs in PIC microcontroller. In 8051, we can capable to write the short programs, but it is not possible in the PIC. I think while we are comparing in CISC and RISC, you have seen that CISC and RISC. Mainly here we have seen that we can write a effective and short programs. That is not possible in PIC microcontroller. Are you clear, ma? This is the only thing we have, and we have a control memory. That's why we have a external, but we don't have a control memory here. These two are the mainly two disadvantage we used to say. The remaining and all, PIC is the advanced. Okay. So I think tomorrow you remember I have seen some of the persons not listening the class, and some of them were listening correctly and answering properly. Especially some of them were attending the quiz regularly good. So I have to appreciate. Tomorrow you remember Wednesday, so definitely I will conduct the quiz for you. The quiz will be from PIC microcontroller. Are you clear, ma? It is from third unit only. Again the Kagoth only will conduct only 10 questions. You all understand it's easy only. So people, please kindly go through the PIC microcontroller and you attend the quiz, ma. Okay, tomorrow we will see the rest of the topic. This unit, third unit, so far we have completed 3 topics: comparison, over. Comparison of CISC is over. PIC architecture is over. Memory organization is over. So tomorrow we will discuss the addressing modes and assembly language instructions. Are you clear? Okay. Now you will answer your attendance.
Ma'am,
Yeah.
ma'am,
What,
what is
Jay
that
Prakash?
12 clock for instruction cycle, ma'am?
Actually,
12.
one very good, very good, very good question. Actually, one machine cycle we used to say. The one machine cycle means there we divide that one, the pre-scalar value is 12 divided by 12. Can you understand? For example, decrement R3 instruction is I am executing. My clock frequency is 12 megahertz. So I have to calculate 1 by 12. That is the time frequency. First we have to divide the frequency. Okay. And then I have to find out the reciprocal. So for that, time executing for one instruction is 1.0485 microsecond. Are you clear? So the execution time period is 1 by 12 there, but here one machine cycle is 1 divided by 4. Can you understand or not? That divided by 12, and here the machine cycle is 1 divided by 4. That is the thing. Are you clear?
But actually, in some processes, we will in ARM-like processes, what we used to see now is like executing a instruction on them, as you said, the fetch queue.
Actually, what is the main advantage on using na? If my frequencies get reduced na, my frequency get increased na, my time period is get reduced. That is the advantage. So if I am dividing my clock frequency by divided by 12, I am performing for each and a machine cycle na. What happen? It taking some 1 microsecond to execute for one machine cycle. But here the machine cycle value will be 200 nanosecond. So it is 1 microsecond, 200 nanosecond. So PIC microcontroller is executing in 1.085 microsecond. Now, sorry, 8051 is executing in mana. Here it is executing in 200 nanosecond. So the time period get reduced. It's clear, ma? So time period, na, the execution is fast. That's why we said it is a high speed, low power device. PIC microcontroller, the processor itself, we see high speed, low power device. So we keep on reducing the frequency, na, my time taken will keep on get increasing there. But here it will be decreased. Jay Prakash?
Yes, ma'am. Thank you.
Yeah. Okay. You understand
Thank you,
that
ma'am.
it is a microsecond, here it is nanosecond. Okay. Uh, I will check the participants list, ma. Uh, register number 1 present, 2 present, 3 present, 4 present, 5, 6, 7, 8. Where is 9? Register number 9 is absent. Especially the 10 is also absent. 11 present, 12 present, 13 present, 14 present, 15 present, 16 present, 17 present, 18 present, 19 present, 20 present, 21 present, 22 present, 22 present, 23 present, 24 present, 25 present, 26 present, 27 present, 28 present, 29 present, 30 present, 31 present, 32 present, 33 present, 34 present, 35 present, 36 present, 37, 37. Jayshri, Jayshri is absent today. 38 present, present. Okay, okay. Actually, why your number is not came here? I don't know why. 38
Network
present.
problem, ma'am.
Okay, okay. 38 present, 39 absent. 39 Jerson absent. 40 present, 40 absent. Jyoti Shankar is also absent. 41 present, 42 present, 43 present, 44 present, 45 present, 46 present, 47 present, 48 present. Tyagi, taken so many leave, Tyagi. I don't know, you are joined. Whether you don't know the class or not, I don't know. What problem? Network issue. 49 present, 50, 50. Mahalakshmi is present.
Absent, ma'am.
Yeah. 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65 present, 66, 67, 68 is present, 69, 69, who is 69 ma? Sai Maniteja absent. 70, 71, 72, 73, 74, 76, 77, 78, 78, 80, 81, 82, 83 is absent. Shriram absent. 85 present, 86 present, 87, 88, 89, 90, 91. Who is 91? Vanmati is absent again. 92, 93, 94, Vinoba present. 701, 702, 703, Monica. Monica is present. Izad present.
Yes, ma'am.
Okay. 703, Monica absent. 952 absent. Okay, ma. So, what, ma?
Ma'am.
Who, ma?
37, ma'am.
37, Jayashree present only.
Ma'am.
I will read out the absentees. Register
you,
number 9, 10. Okay. 39, 40. Then 69, 91, 703, 952. These are the absentees. I don't know still in online this much of absentees I'm facing. So people, please see, sir. So tomorrow, at the last, I will conduct the quiz for you.